on to number 7. Determine the number of protons and the number of neutrons in the nucleus X. Right, so our alpha particle, this here, it can be written as, it's a helium nucleus, so it can be written like that. So in other words, we are saying from 238 we have removed 4. What is left over after removing 4 from 238? We are left with 234. Right, this is the nucleon number. What about the proton number? From 94 we have removed 2, so we are left with 92. That's the proton number. So number of protons is 92. Right, what about the number of neutrons? The number of neutrons is, it's 234 minus 92 to give us 142. That's the number of neutrons. Now on to B. For us to get the number of plutonium-238 nuclei that's required there, we need to remember that power is work done over time taken. So work is power times time. So 0.15 watts times 1 second to give us 0.15 joules. Right, so we need this much energy. Alright, so we have been told that this much energy is produced. This much energy is produced when one nucleus, this is for one nucleus, when one nucleus reacts. Right, how much is 5.6 mega electron volts? We can find here the number of joules in 5.6 mega electron volts. Each electron volt is 1.6 by 10 to the minus 19 joules. Right, so if we do the math, we get 8.96 by 10 to the power minus 13 joules. But this is one nucleus. So one nucleus is giving us this. One nucleus. So how many nuclei do we need to get 0.15 joules? Right, to get 0.15 joules, we need this many nuclei. 0.15 divided by 8.96 by 10 to the minus 13. This is the number of nuclei. Right, we get, from that we get nuclei needed.